All right, guys, this is notes number 2. In our textbook, we're combining chapters 1, section 1, and the end of the chapter, 1.7. We're going to talk about average rate of change, which is huge on our AP test, and our first type of regression, linear regression, also pretty prevalent on our AP test. So, average rate of change, which you can abbreviate as AROC, is the basically just the slope between any two values on any function. So average rate of change, you should just be thinking slope. We have an official formula for this, which is always good to write out. Average rate of change is f of b minus f of a over b minus a. And that would just be like, go ahead and plot a point on your curve. Let's say this is the input a and it has an output f of a. Put another point on there. This one has an input of b and an output of f of b. And so, yeah, the slope between these two lines is the average rate of change, or between these 2 points is the average rate of change. And depending on which 2 points you pick on a curved graph like this, we will get different slopes between different sets of points. Don't let the formula overwhelm you. It's just saying, give me the change in the y values over the change in the x values. This little delta here just means change. And go back to the slope formula you learned in 6th or 7th grade. That's just y2 minus y1 over x2 minus x1. So please do not overthink average rate of change. We talk about it a ton in this class, and then you'll talk about rate of change a lot in calculus next year. We might need to interpret an average rate of change. So you need to have a couple of phrases. I have sort of a script for you. You need to start with on average, because an average rate of change is not the perfect slope between any 2 points on a curve. It's just an average between the 2 points you've picked. So on average, and then we would say, in context, we would say the y value is either increasing or decreasing. This is if your slope is positive, y values are increasing. If the slope is negative, y values are decreasing by whatever your AROC is, whatever that number is. And then you need units. So the units will be y's per x. But put that in context again. All right, so all of this needs context, of course. We're not going to actually use x's and y's in our statement. Now, we like to get asked this question: when is the average rate of change the greatest or the least, or what's the largest average rate of change versus the lowest? This doesn't always correspond to the steepness of the slope. If all your slopes are positive, then yeah, the steepest one will be the highest. But if you have a collection of positive and negative slopes, it's not always the steepest one that would be the highest or the lowest. So just think about numbers. So this is comparing just the numbers themselves. So without thinking about steepness, if I said, okay, we've got a handful of slopes here. Between 2 points, we've got a slope of, say, 10. And then between another 2 points, maybe we have a slope of 2. How about 1/2? There's a 0 slope somewhere. And then maybe I pick 2 points and the slope is negative 1,000. All right, so where is the AROC the greatest? Well, if these are all AROCs, the greatest is just the highest number. So greatest AROC, it's not the steepest, because the steepest would be this negative 1,000, but the greatest was 10. And the lowest, which seems weird to say, but the lowest is negative 1,000. It's the most negative. If I had a bunch of negative numbers and maybe it was like all of these were negative, negative 10, negative 2, negative 1/2, 0, negative 1,000, 0 would be the highest, because the closer you are to 0, the higher your number is with negatives. Okay, we're going to be using, I'm getting ahead of myself. We will have lots of data sets to look at. So this says use the scatter plot shown below to answer this question. I want to find and interpret the average rate of change of the sales of Goodyear tires between the following years. So before we get into this, let's take a look at this graph. The vertical axis says sales in billions of dollars. The years range from 5 to 14, and it says 5 is equal to 1995. And so we want the slope between 5, and 8. So you will need to show your work for this on the AP test. So I don't really have a function, but I'm going to show the numbers that I'm plugging in. So when we're at 5, we have 13.2, and when we're at 8, we've got 12.6. So I'm going to say, okay, 13.2 minus 12.6, and then make sure you subtract in that same order. 13.2 went with 5, minus 12.6 went with 8. You can switch the order of these, 12.6 minus 13.2, then it's over 8 minus 5. All right, now, in this class and on this AP test, you're allowed to either use your graphing calculator, or I'm going to primarily ask you to use Desmos. So now we could probably do this one without a calculator maybe, but I want you to get used to using Desmos, so you can hit the divided sign to do this, and then it's 13.2 minus 12.6 over 5 minus 8. I like Desmos because there's less room for error. In your calculator, you need to write parentheses around a lot of things, where you have to know where to find certain keys and stuff. So this is just kind of more straightforward, I think. So this is negative 0.2. And then we need to interpret this. Remember, this represents sales in billions of dollars, and it's negative. So the sales are decreasing. You can see that negative trend from 5 to 8. So I'm going to say, on average, the sales, I'm not going to get too into it with wordiness, like sales of Goodyear tires. I'm just going to say the sales are decreasing. Now, when you use the word decreasing, you're going to leave off the negative here. Decreasing by how much? By 0.2 billion. I could put the dollar sign in here or write $1 billion per year. Because remember, the label is Y is per X, so $1 billion per year. What about between 10 and 14? So here's 14 and here's 10. It's going to be a positive slope, even though there's a bit of decrease in here. Overall, that trend was positive. On average, I should say. So AROC is going to be, show the work for this, 18.4 minus 14.4 over 14 minus 10. I don't think I need a calculator for this. 18.4 minus 14.4 is 4. 14 minus 10 is also 4. That's coming out to a nice clean 1. And so my interpretation is almost the same. On average, these sales are increasing. I abbreviated here. I probably should write the word increasing by, this is 1 billion. So $1 billion per year. I'm using the dollar symbol. You can write $1 billion, the words per year, doesn't matter. Was the average rate of change greater between the years 5 to 6 or 7 to 8? I thought I fixed this. Hold on. Did I change this question for you guys? Let me see. Oh yeah, sorry. I had an extra. I thought I fixed that here. Oh well, anyway, let me cut over to this. So the question that I wanted to ask was the average rate of change greater from 5 to 8 or 10 to 14? Now, again, don't overthink the problem. It's not about steepness. It's just saying which number is higher. So from 10 to 14, we definitely had a larger slope, right? 1 is bigger than negative 0.2. So when it says justify your answer, it doesn't have to be a big long paragraph. I'm just going to write this out. So the AROC was greater. It's good to just restate the question basically in your answer. Between t equals 10 to t equals 14. Why? Because, just show the numbers. This is proof enough. Because 1 is greater than negative 0.2. That's it. That's all you have to write. Nothing crazy. Okay? So what about working with data? So what about regression models? Our AP Pre-Calculus test has a pretty large focus on modeling in general, making sure we have models or equations that can kind of best fit some of this data. And so we're going to start using regression to determine the strength of a model. Let me flip back to this. Okay, So a scatter plot is just a graph used to plot bivariate data. So that's just two variables. You've got an input and an output into a series of ordered pairs, and we don't connect these points by lines or curves like we did on the previous one. It's just sort of a scattering of points. Now, you can create a scatter plot in your graphing calculator. If you're in AP Stats, you'll learn how to do that. If you prefer the graphing calculator, come see me in office hours, and I will show you how to do this. But the first thing I want to do is figure out how to graph this data. This is, it says this data table shows the outstanding household credit market debt, capital D, in trillions of dollars from 1998 to 2004. Construct a scatter plot. Now, I've got screenshots of how I'm doing this here, but I'm just going to go through this in my real time here. So when you're in Desmos, you can hit this little plus sign. And on our AP test, our only options will be expression or table. So we're choosing table. We should enter this data instead of 1998. Sometimes that can kind of confuse calculators, especially. So I'm going to enter 1998 as 8. So I just enter 8 and hit enter, and then 9, 10, that's 2000, 11, 12, 13, 14 is 2004. Now go in and make sure you're typing in correctly the inputs. You don't have to put in the point zeros. I'm just doing it because it will help me when I do a quick check that my numbers don't have typos. It'll help me see that they match up a bit better. So I'm just quickly double checking these. Okay. Now, when you type in a table set like this, you should automatically see this little zoom fit icon. Click that. That goes right to the data set here. And then you should see this little guy up in the corner. What I want to do is create a linear regression, which is just come up with a line of best fit. So go ahead and click this. And linear regression is the first choice. As we go throughout the year, we're going to look at most of these other types as well. But you can see it gives you this nice little equation. That's a pretty good line of best fit, it looks like. And one other thing you can do if you want to use this equation to predict further values, you can hit this little, what is this, a piece of paper or something? It says export a snapshot to the expression list. So click that, and it types it down here for you, which is pretty cool because then I can start using this to like plug in values for X. All right, so one other thing I want to show you, by the way, you could also type in your own equation. And the reason I want you to know how to do this is because sometimes they ask us to do a very specific regression that's not just y equals ax plus b, and we would need to be able to account for that. So another way to do this is y1, I'm doing a little underscore 1 and then arrowing out of that, is about equal to, this little tilde symbol is to the left of the 1 on my keyboard, a plus b times x underscore 1. And see how it gives me the same equation, right? It just gives it to me in a slightly, it just doesn't write out the equation here. It tells me here's a and here's b. What's this r and r squared? You will learn more about correlation and the coefficient of determination in statistics if you take it. But basically, the closer this number is to 1, the more accurate the line of best fit is, or like the better fit this is for the data points. If they were really far scattered from the line, this would be closer to 0. All right, so that was a lot of information. Let's go ahead and write down this equation. So one thing I will ask you to do on a test or a quiz or homework is, write down your regression line. So it would be like y, actually not y though. They're using d and probably t for time. So d is equal to, we can round this to 3 places for our answer, times x plus 0.025. And maybe instead of x, what did I just say? T probably. So that's my model. But I want to use the unrounded version if I'm going to do any math with it. So this says use the linear regression model from example 1 to answer each question. Use the model to predict the household credit market debt in 2005 and the debt this year. So, okay, 2005. that means I should be finding D of, what would 2005 be? It would be 15. And if I do that, I can type that into Desmos really easily. So I can say, all right, let's get this off of here. We don't need that second line. So remember how we put this in here? Let's put the X in parentheses. And instead of X, let's just type in 15. What does that come out to? 10.686. We always round to 3 places for our AP test. And actually, if they tell us to give them a decimal approximation and we don't round to 3 places, they won't give us the credit because we're not following directions. It will say on the test to round to 3 decimal places. So $10.686 trillion. All right, what about here? I don't want to flip my computer around again. Let's see, what's the current year? So let's see, 2025. Right now for me, it's 2025. So I set this up so that T was year since 1990. So 10 years to get you to 2000 plus an extra 25. That seems like that would be D of 35. So in here, I want to put 35. This would round 899, would round up to 900. So 24.900 trillion dollars. You should be in the habit of labeling your answers anytime there's context. What about residuals and residual plots? So this is something that maybe will pop up a time or two for our AP test. You'll see this a lot in AP stats. A residual and a residual plot helps you answer the question, is this model overestimating or underestimating each value? And then, how far off is it? What is the error? So the model is the line. And so is the line over the data point or under the data point? And the error is how far is the line from the point? Take a look at this picture. This point is very close to the line. It has a small error. This point is a bit farther above. It's got a larger error. This is sort of in the middle. Which points have a negative residual? So what is a residual? A residual is really just that distance from the point to the line. So a residual, in general, is like the actual y value that you have, the data point, minus the predicted, or the data point predicted y value that the line says it should be. So which one has a negative? Well, it would be any point that's below the line of best fit. So this is a negative residual. And this, even though it's barely under, that's a negative residual too. So let's call these points A, B, and C, just to simplify things. So points A and B have negative residuals. Is the line over or underestimating that output? So just follow that question. Is the line over those points or under them? It's over those points. So the line or the model overestimates these outputs. It just means the line says the y value is going to be a bit higher than what it actually is. The data points are what's actually happening. Which point has a positive residual? So that's point C right there. That's a positive residual. It's sitting above the line. The difference is positive. And so that would be point C has a positive residual. And the line is underneath this. So the model or the line is underestimating the output. So it's just saying the point at C is going to be, with this input, you're going to be a bit lower than what it actually is. And then error is just what is the actual minus the regression. So error is the same as the residual. So list the 3 points in order of lowest error to highest error. So the lowest error would be the closest to the line. and the highest error would be the farthest from the line. So if I'm looking at these, it looks like it would be points B. That's definitely the closest. It doesn't matter above or below. A looks a bit closer to me than C, and then C would be the last one. All right. How can you find residuals in Desmos? So once you've already run a regression, let me go back to my Desmos here. I've already run regression. See how there's this little thing here that says residuals. So residuals, you can just click plot. And so it puts residuals in the table. So I can look at this and say, okay, so now I can see without even looking at the graph, the 0.86 is a bit above the line of best fit, whereas the 0.9, 6.4 is a bit below. What if you wanted to look at a graph of the residuals? So the residual plot, now there's like this little zoom fit option. So let me go back to that. So what they've done here is take the point and just say, okay, 0 is like a point was perfectly on the line. This first point had a residual of 0.289, so it's sitting way up here at 0.289. This next one had a residual of negative 0.02, so that's just this little bit below. Another negative, another negative. So here's another way to say, well, what's the largest residual? This one at 14 has the largest value in absolute value. All right, we don't often have to plot our own residual plots, but it's just kind of, this is all just saying how close are each of the data points to that line or whatever the model of best fit is. All right, and here are some other types of non-calculator AP questions. This will help you when we do some multiple choice problems in AP Classroom. So the table below shows represents a linear function, f of x. So linear function means we should be able to find a slope. Then we can easily write a point slope equation with any one of those 3 points. Without a calculator, use the data in the table to find f of 9. So we have f of 2, f of 5, f of 8. We want to figure out what's f of 9. So I just need the slope for this. So the slope, or the average rate of change, it could be the slope between any two of these points. It does not matter which two you pick. I'm just going to pick the first and the last. 20 minus 2 over 8 minus 2. 18 over 6. Slope is 3. If you picked the first and the second points, you'll still get a slope of 3. If you do the second and the third, slope of 3. It does not matter. So because we know, we're told this is a linear function. So the slope is 3 for sure. Now, 9 is only 1 unit away from 8, so I should just be able to add 3 here. But just in case we do something like, what if it said find f of 19? Do you really want to add 3 until you get up to 19? Not necessarily. So remember, we learned about point slope form, where y minus y1 can equal m times x minus x1. Our AP test free response question, there will always be something that says find some value using the average rate of change. So you can just say, all right, I'm going to plug in, I'm going to say this point, 2, 2 is my x1, y1. Why not? Use one of the points that you used for slope. So that'd be y minus 2 equals 3 times x minus 2. Now, instead of x minus 2, I want to find y of 9. So that should be 3 times 9 minus 2. And then I'd have to add this 2 over. So y of 9, or f of 9, is equal to 3 times 7, 21, plus 2, 23. Better call it f of 9 just to be safe. Now, did I need all of that work? I could have just added 3 here. No, but if I said find f of 109, you don't want to keep adding 3 until you get out there. You want to streamline that process. All right, last question. The table below shows the average rates of change for various intervals of x. So this is the AROC of f of x, or sometimes they say it's the change of f of x, but we have to be careful here because this AROC is per unit. So this means that the slope, like if we're looking for over which interval does f of x increase the most, it's like, well, duh, 30 is the highest number, so that's it. but not necessarily, because this is saying on the interval 0 to 1, you increase 30 units for every x value that you increase by 1. So like it's really 30 times 1 minus 0. So yes, there has been an increase of 30 units from 0 to 1. But if this went from 0 to 2, there'd be an increase of 60 because you did 30 over 0 to 2 units, right? So take a look at the next ones. They're not all just 1 unit long. So the next interval is 1 to 5. You've got a slope of 8, but you do that for 4 units, 5 minus 1. So 8 times 4 is 32. So there's actually a higher increase on this. Even though the slope is lower, it's taking this lower slope and going for a longer amount of time. All right. The negative slope's not going to be an answer, but I just want to show the calculation anyway. That's a negative slope of 40, and you're doing that from 5 to 6, so for 1 unit. So that's a decrease of 40 units. And finally, the last slope is 0. So if we do a slope of 0 for it doesn't matter how many units, we will have increased or decreased 0 units. So these two are an increase, this is a decrease, and this is just nothing. The question was, where does f of x increase the most? So on 1 to 5, f of x increases the most. Now, what's with the brackets and whatever else? Maybe some of these should be parentheses, but that's not really the part to get hung up on. I'm just going to copy the work in the problem and go ahead and use closed intervals for that. All right, hopefully this helps you get into Desmos a little bit and work with average rate of change. Please let me know if you have any questions.